Unit 3 Grammar. So, when we discussed about the previous units, that is finite automata and regular expression, so we are discussing about regular languages, right? So, regular languages are accepted by finite automata, and there are two types of finite automata. One is without output category, another is with output category, right? Without output category, you studied about DFA, NFA, and epsilon NFA. With output category, you studied about Mealy machine and Muri machine, right? So, finite automata is nothing but acceptors. That is, the regular languages are accepted by using the machine finite automata. So, finite automata is an acceptor. Okay. In the second unit, you studied about representators. Representators are the mathematical representation of regular language, that is known as regular expression. Okay, so regular languages are represented mathematically by using regular expression. So these are the representators. Now you are going to study about generators. Okay, generator. Generator is nothing but grammar. Okay, so in this unit you are studying about grammars. Okay, so generating means what is acceptor. So suppose this is our language A, 2A, then 3A, etc. So if I want to check whether AB is present in the language, so it will linearly check with every string, right? So if the string is present, then it will be accepted by the automata. And we can represent the language by using a regular expression. That is this one, representatives, right? Then if I want to generate all the strings in the language, we can use a grammar, that is generator. So to enumerate all the strings in the language, so in order to generate all the strings in the language, we can use a generator, that is grammar. And grammar two types, right linear grammar and left linear grammar. Okay, so we will study all the things in this unit. So what is a grammar? So a grammar is a set of rules, finite set of rules. Okay, grammar is a finite set of rules which is used for generating all the strings in the language, that is generator. So a grammar is a generator and is represented by using 4 tuples. So G is the grammar, represented by using 4 tuples V, T, P, S. V means it is a finite set of non-terminals or variables. Okay, non-terminals or variables. T means terminal, set of terminals. P is the production rules, set of production rules. And S is the start symbol of the grammar. Okay, so a grammar is represented by using 4 tuples V, T, P, S, where V is a finite set of variables or non-terminals. What are things you are in capital letter, that is variables. We can replace the variables only in the grammar with a corresponding production. T is the terminal symbols, that is terminals you can see in the leaf nodes. In small letters you can see terminals. P is the production, all the productions available in the grammar. S is the starting symbol of the grammar. See, in this example, S equal to, this is a grammar. Okay, here this is a starting symbol. So starting symbol is S. And which are the variables here or non-terminal? What are things you are seeing in capital letter? So these are variables, and terminals are what are things you are seeing the small letter A, B. And productions here are, which are the production? S gives A, S, B, comma, S gives A, B, comma, B gives B. So these are the productions in the grammar. Next topic is derivation. What do you mean by derivation? If we are having some grammar and we are generating, so what is the use of a grammar? Generating all the strings in the language, right? So we are deriving all the strings from a given grammar. That process is known as derivation. Okay, and there are 2 types of derivation. 2 types are there. 2 types. One is leftmost derivation, another one is rightmost derivation. Leftmost derivation means left, right? That is replacing the, suppose this is our production. Okay, this is the leftmost non-terminal, this is the rightmost non-terminal, right? So we can replace only the capital letters, that is the non-terminals, with some production. Okay, so leftmost derivation means we are replacing the leftmost non-terminal. Rightmost derivation means we are replacing the rightmost non-terminal in the production. Okay, so we are replacing with the right, in every step we are replacing the rightmost non-terminal only. That is the rightmost derivation. Leftmost derivation means we are replacing only the leftmost non-terminal. Okay, we will see with one example. Let's see, this is our grammar. We are going to generate the string AABB from this particular grammar. So here, which is V here, variables here are capital A, capital B. Terminal symbols are small a, small b, right? These are productions. Productions are A gives AAB, A gives small a, capital A gives epsilon, then B gives BB, B gives epsilon. So these are all the productions here. And start symbol here is A. This is the start symbol of the production, right? So we are going to derive the string by using the above grammar. This string we are going to derive from this particular grammar. Okay, so first I am using leftmost derivation. Okay, so I need to derive AABB. A derives, you can take any production depending upon the corresponding string that we are going to derive. You need to take the corresponding production. Okay, so I am taking AAB. Leftmost means this is a non-terminal, this is also non-terminal, capital letter, right? So leftmost derivation means replacing the leftmost non-terminal. Okay, so I need AABB. So I am replacing A with small a, capital A, because A gives AA. The user production here is A gives AA. So I am replacing capital A with A and the B as it is. I need AABB. So I got small a, small a. Then I need B, right? So again I am going to replace this thing, right? So I am replacing A with, I need to eliminate A. So I can use the production A gives epsilon. So epsilon means nothing. So only B here. You don't need to write epsilon here. Okay. Then I have AA. I need two B's here. So instead of B, I can replace it with the production B gives BB. So instead of B, I can use BB. So B. Now I got AAB. I need one more B. So again I am replacing B with BB. AAB, BB. Now I need to remove B. So we can see the production B gives epsilon. That is B gives epsilon, it will get AABB. So I got AABB by using leftmost derivation. Right? By using rightmost derivation also, you can derive the string AABB. So I am taking AAB. So rightmost derivation, rightmost non-terminal I need to replace. In leftmost derivation, I need to replace leftmost non-terminal. In rightmost derivation, I need to replace the rightmost non-terminal. So I need to replace this with B gives BB. So I am replacing B with BB. Because B gives BB is the production here. You can see, you can take any production depending upon the string we are going to derive. Then this is a rightmost non-terminal. Again I am replacing this with BB. That is the production used here is B gives BB. So this B I am replaced with BB. Now I need to eliminate B because I need AABB. So I used B gives epsilon. So now I have, okay, this B I replaced with epsilon. Now I need, what I need? AABB. So next rightmost non-terminal, here only one rightmost terminal. So I am replacing this with AA. So A, BB. Now I can make A, that is I can use the production A gives epsilon. So I got AABB. So I derived the string A, B, B by using rightmost derivation. And this is a leftmost derivation. So this is our derived string, and these are known as sentential form or sequential form. Okay, that means these are known as sequential form or sentential form. That is, these steps are known as sequential form or sentential form. This is the derived string, and the entire process is known as derivation. Okay. Next topic is derivation tree. So this is another representation of getting the string. Okay, so we just use the pictorial form, that is representing by using pictorial picture, that is by using a tree, that is the derivation tree or parse tree. So suppose we have this grammar and we are going to generate A, B, B. So you already know before the string what are things we have. These are known as sequential form or sentential form, and this is a derived string. The entire process is known as derivation. So like writing these, we are representing by using a tree. That is, S gives ASB. S gives ASB. See, S gives ASB. I am replacing S with AB. Okay, I am replacing this with this B with B. I am replacing this with B depending upon the production. Then I am parsing from the root. A, B, B. So I got the string A, B, B. So this is known as parsing. And the tree is known as parse tree. So this is another representation of getting derivation. So hope you understood what is a grammar, what is a derivation, what is a derivation tree. Right?